Hello and welcome to 6.5 day 2. We are going to be talking about what to do with radicals when we're multiplying and adding them together. So this is our day 2 page of notes. So what I did is I created my own little examples off to the side over here so I could walk through each of them with you. It's kind of windy out here today, so I'm going to use my stapler to hold the paper down so I can write. Alrighty. So, the important thing to know when we are, first of all, let's look at example number 1 here. I have steps written out, and then I also have my example here. So, the important thing is to just kind of identify that each of these have the same type of square root. So, like these ones, this is the second root because there's no number, so we can assume that it's an invisible 2. So step 1 says all the numbers on that little ledge there under need to be the same nth root. So just like I said here, we have a 2 here and a 2 here. If we had both 3s here, then we could do those ones together. If we had both 4s, then those could be joined together. Same thing if there were 5s or any other number. So that number needs to be the same for both parts of the problem. So what we're going to do is we're going to multiply the numbers as usual. I did a little mini example here off to the side. So if we take a peek at, we got a shadow. If we take a peek here, what I did was I just created my own little example here, and I just multiplied 2 times 3. Those numbers are both on the outside of the square root. So I just multiplied those numbers together to get a 6. So when it says multiply your numbers as usual, that's simply all that you have to do is just multiply the numbers on the outside of the square root. So if we're looking at this first example here, since I know that those two are both the second root, I can do 2 times 5, which gives me 10. And then I have the square root of 3 times the square root of 18. Oh, darn. I should probably have my calculator out here with me. Pause. All right. I'm back. Calculator obtained. Okay. So we've got, let's see, 3 times 18. Oh, I can't even see my calculator. 3 times 18 gives us 54. So let's make sure I'm in the right spot. All right. I've got 54 here. And let's see. So looking at our steps, it says radicals are multiplied together. Okay, cool. I just did that. And the outsides are multiplied together. Yep, already did that. Step 5, simplify. Okay, so here's the thing that you need to remember. So we have 10 root 54. I know that 54 already breaks up into 3 and 18 because that was kind of like given to us. So I've got 3 and 18. I'm just going to use those same numbers. That one's done. 18 breaks up into 2 and 9 or 3 and 6. I always think of, 3 and 9. No, 2 and 9. Yeah, I was right. 2 and 9 or 3 and 6. Those are ones I just like to use. I don't know, because I know 9 breaks up into 3 and 3. And then I know that 9's a perfect square root. That's why I like to do that. So now I have, let's see. Yep, you guys can see that. All right, good. 10 square root of 2 times 3 times 3 times 3. Right? So that means I just need to, since it's the second root, when there's nothing there, it's the second root. I need to find pairs that are the same. I have 3's, 1, 2, there's 2 of them, and it bumps outside. When we do that, we've got a 3, and we need to multiply these numbers together. So for step 4, it says radicals need to be multiplied together and outsides are multiplied together. So since we had 3 here, and we moved that outside, those have to be multiplied. So 3 times 10 is 30. square root of 2 times 3. You can write that as your extra step, or you can just go ahead and multiply that together to get you your 6. So there you have it. There's example 1. Let's take a look at example number 2. All right, so it says to add the exponents. So this one has letters, right? You see how this one has x to the third, y to the fourth. This one has x and y. So what we need to do is we're just going to add the exponents for each of those. So x to the third and x to the seventh. That gives me the square root of x to the 10th. And I have y's, and I have y to the fourth and y to the second. 4 and 2 gives me 6. So I have the square root of x to the 10th power and y to the 6th power. And now because that's an invisible 2 that sits out on that ledge because it didn't say otherwise that it was something else. You guys see that okay? Yeah. So then basically all I have to do is just take that number and divide it by each of these. Divide by 2, divide by 2. And since both of these divide nicely, the square root symbol is going to go away. So if I take x and I do 10 divided by 2, yep, I'm going to get 5. So I've got x to the 5th, and that's done. And then I have y to the 6th divided by 2, which is 3. So I have y to the 3rd. The square root symbol goes away because it simply just reduces to x to the 5th, y to the 3rd. All right, not too challenging. The next couple of problems we're going to get to be a little bit more involved. So we're going to move over here to example 3. And we've got, let's see. All right, perfect. I can see the screen. All right, so I got to make sure that these two are the same. That's step 1. Make sure that they have the same nth root, which they do. And then step 2 says to multiply, well, technically there's an invisible 1 out here because there's no other number. So 5 times 1 gives me 5. So I have 5 third root of 100 times 10, which is 1,000. And then I have a to the 2nd times a. All right, so now we just need to simplify, break that down. And just how I said, this one had 100 here and this one has 10. My 1,000 is going to break up into 100 and 10. 10 breaks up into 2 and 5. 100 breaks up into a lot of different things. Let's do 25 and 4 because that'll give us the least amount of work. If you couldn't think of that, I just think of quarters. There's 4 quarters in $1. You could have done 2 and 50. You could have done, well, there's 4 and 25. You could have divided it by 5. You could have divided by 20. You could have divided by 10, so you would have 10 and 10. Lots of different things, okay? So here we've got 2 and 2. 25 breaks up into 5 and 5. Just double check that you can still see my work. Yep. It is super, super sunny out here today. All right, this one's done. This one's done. And I'm left with, let's see here. We've got 5 times 5 times 2 times 2 times 2 times 5. So I have 3 2s. 1, 2, 3. And then I have, oh, I wrote a 3. That's funny. I've got 2s. And then I've got 3 5s as well. So 5 times 5 times 5. And I've got a to the 3rd, because if I have 2 here and I have an invisible 1 there, we've got a to the 3rd. So that's kind of like step 3. Step 3 and 4. So I'm going to take my 2, and it's going to bump to the outside. And I'm going to take my 5, and it's going to bump to the outside. So now I have 5 times 2, which gives me 10. And then under the square root, I'm left with a 2 and a 5. So I can do 2 times 5, and I have a to the 3rd. Keep going. I've got 10. What root? Third. We're working with the third root. We always got to make sure we... Oh, third root. That's why we check our work. 3 numbers that are the same. 1, 2, 3. What's the same? 2s. It bumps to the outside. 3, 5. I need 3 5s. 1, 2, 3. 3 5s are the same, and it bumps to the outside. So there is no number left under the square root right now. We just have 10 third root of a to the third. And then since that's the third, I can divide that by 3. A to the third divided by 3. 3 divided by 3 is 1. So I have a to the first power. And there's nothing left under the square root because the numbers went away and so did the letter. All right. Moving on to example number 4. I've got, this is the second root, this is the second root. Let's see, can we see this? Yeah, we can see this whole problem. Okay. So this is example 4. I've got 10 times 3. 10 times 3 is 30. 10 times 3 gives us 30. All right, and then we're going to take, that's done, and that's done. We're going to take our 5 times 15. 5 times 15. So we've got 5 times 15 equals 75. So I've got 30 root 75. And remember, this is the second root. So I'm going to put my little 2 there. And then we've got, I wrote that out. X to the first. And then x to the 7th. So I'm going to add my exponents. So I have x to the 8th. X is done. X is done. Now I got to do my y's. And I have y to the 4th and y to the 3rd. That gives me y to the 7th. And then I need, let's see, there's no z's here, but there are 6 here. So I have z to the 6th power. That one's done. All right. So I can take my 75, and that breaks up into 5 and 15. 5 is done, and then I have 3 and 5. So we've got 30 still on the outside. It's the second root. So I've got 30 square root of 3 times 5 times 5 x to the 8th power, y to the 7th, and z to the 6th. So what I'm going to do, since that's the second root, I've got 2 here. There's my 5s. It bumps out. 5. Now I need to multiply my 5 times 30. 5 times 30 gives me 150. So I have 150 here. And that's the second root. And I've got 8 x's, and I've got y to the 7th, and I have z to the 6th. So I need to, since this is the second root, I need to divide each of these by 2. 8 divides by 2 nicely. 7 does not divide by 2 nicely, but 6 over here does. It's a funky 2. All right, so now what I can do is I have my 150. I kind of want to give some space in between. I've got 150 here, the second root, and then this gives me, if I have x to the 8th divided by 2, 8 divided by 2 is 4, so I have x to the 4th, that's done, and then here I have y to, let's see, 6 divides by 2 nicely, 6 divided by 2 plus 1, and then I have z, 6 divided by 2, because z to the 6th power, and then we have 150, x to the 4th, then this here, I'm going to draw my second root here, okay, I have y to the 6th divided by 2. 6 divided by 2 is 3, so I have y to the 3rd. That part's done, but I have 1 left right here. Ooh, can we see? Yes. Okay, now we can. So I did 6 divided by 2 was 3, so I had y to the 3rd plus 1. So I have y to the 1st because there's 1 left right here. Now I have my z, and z to the 6th power divided by 2 is 3. So I have z to the 3rd. There is my final answer. Voila. All right, so if you turn to the back side of your notes, we're going to take a look at, where are we at with time? Ooh, we're at 15 minutes. All right, this is going to be longer than our 25 minutes that we've allotted. So if you need to pause and pick it back up tomorrow, that's fine too. Or you can come back to it on Wednesday or Thursday later in the day. But I'm going to continue on with our notes here. Okay, so the back side of our 6.5 day 2 notes talks about adding and subtracting our radicals. All right, so the important thing to know here is that we need to identify 2 different things. Number 1, we have to identify what the index is. So for number 1, I highlighted the 2 sitting on that little ledge of the square